Apostrophe CMS onboarding series. Widgets. Part 3, creating a feedback widget. What's a review site without the ability of the authors and readers to submit ratings? To wrap up our tutorial on widgets, we will take a look at another way to deliver template content and begin the creation of our ratings widget. We will create a section for editors to add their product ratings from a set of schema fields, and a way for readers to submit their ratings on the front end. This will highlight an important aspect of widget creation, adding a player for front-end JavaScript. Again, you can follow along with the tutorial to modify your own project, or to see the progress of the project while following this tutorial, switch to the sec2-4-widgets branch of the Apostrophe onboarding project repo on GitHub linked in the comments below. Let's take a quick look at what we'll be building. On the left side of this widget, there will be 3 sets of rating stars. The content manager will be able to change some range schema fields to determine how many filled stars will be displayed on any page where we add this widget. On the right side, visitors to your site will be able to click on a star in each category and then click the Submit button. This will send the rating back to the database, which will then return the average rating in each category to display to the reader. Once again, we're going to use the CLI to create our new widget with one slight difference. This time, we're going to pass the player flag. This will create a widget that has the expected index.js and widget.html files, but also a new set of nested folders with an index.js file inside. We will come back to this when we add the Widget Player code to collect the browser-side user feedback. For now, we're going to focus on creating the schema fields to populate the left side of the widget. Let's go ahead and switch to our code editor and create the widget. We will add our new widget to the app.js file, and then we'll open up the index.js file of the new module. Next, I'll paste the code in from the written tutorial and walk you through the schema. While the schema fields in this code are of a new type, the majority of the code should look familiar. The range field type allows the developer to specify a range of numbers from min to max that the user can enter using a slider. You can optionally add a step size that determines the interval between each value. This code adds 3 different schema fields to collect quality, safety, and value ratings, all added to the Basics tab. The last section of code is the novel part. In our template, we want to convert the number entered by the user into stars displayed on the front end. We could use a loop directly in the template, but we would have to add the loop code to the template 3 times, once for each schema field. Instead, we will use an async components customization function. Components are a little like fragments. Unlike fragments, however, you can run a database query or fetch information from a third-party API to populate it. You can also access site information to further customize your widget to things like locale. At the moment, this component is very simple. We will expand on it when we add the readers section of the widget to collect information on the front end. A component function takes the module as an argument and returns an object of functions that can be used within templates. There are 2 differences from the helper functions that we have already learned about. First, helpers must be synchronous. Components can be asynchronous. Second, components return markup to the template rather than a value or object. In the code for the components configuration method, we are returning a single function named stars. This function takes 2 arguments, rec, the request object from the originating template, and data, an object with the data payload passed from the template where the component is used. Our component method is then returning an object with a stars data property set to the stars data value sent from our template. This data payload is then sent to our component template, stars.html. As covered, components return markup to the original template. The markup being returned here is derived from another template, stars.html, named with the same file name as the component method name. This template has access to the data returned by our component method on the data object. Now that we have the first part of our async component created, the component function, we need to create our component template. Create a modules/rating-widget/views/stars.html file and add the following code. Again, I'm going to paste it in and then I'll walk you through it. This template contains a simple for range loop that will increment a counter from 1 to 5, not including the stop value of 6, and then compare that value to the star value entered by the author. If the counter value is less than or equal to the entered value, a filled star from the Font Awesome library is added. Otherwise, an empty star from the same library is added to the markup. So I can hear those in the back mumbling, don't we already have an icon library? Why don't we just register a new one from there? While it is true that we have a library of icons, they are all view components for use in the admin UI. We need a different set of icons for the front end. The last part for our async component is the markup for the widget, where we actually pass data to the component function and then insert the HTML that is returned from the stars.html template we just created. Open the modules, rating widget, views, widget.html file, and replace the existing content with the following code. I'll paste it in from the written tutorial and then walk you through it. Our template for this widget is almost all straight HTML markup except for 3 calls to our component function. Within each div with a class of font awesome-rating, we have a nunchucks tag, component, rating widget : stars, with stars data : data widget. This is saying that we want to use the component function named stars defined in the rating widget. To call a component method defined in a different module, it would be changed to component custom module : method name. We are passing an object to our function using with. In this case, it is an object with a single property, stars data, that will be available in the data object passed to our method. In each component call, we are passing in the schema field value for that category, whether quality, safety, or value. You can pass any data available in the template to the component method in this manner, although passing the entire template data object can cause performance issues. The last step we need to perform to get our rating widget ready to add to pages is to add the Font Awesome font that we use for displaying the rating. Font Awesome is available as a CDN delivered resource, so we're going to add it to our project in this way. There are a number of areas where we could elect to add this resource. If we plan on using the font in other areas of the site, it might make sense to add it to a style sheet loaded in the Modules, Asset, UI, Source folder. In this case, we're only going to be using it in the rating widget module. So instead, we will create a modules, rating widget, UI, source, index.scss file, and add the following code that I'm going to copy from the written tutorial. Here we are importing the Font Awesome font and also a file for the additional widget styling. The additional styling is going to be very simple, but I like to mainly use the index file to import other files, not directly add style rules. Create the modules, rating widget, UI, source, SCSS underscore font awesome stars.scss file, and add the following code. At this point, if you wanted to, you could add your new widget onto a page and spin the project up to see what it looks like. In the end, we are going to add it into our review piece, but for now, you can add it to the area in the default page module and the lib/area.js file in the full config section to be able to use it on the home page. Once again, you may need to remove the apos build and data temp folders, plus start up with the apos dev variable set. We have now built an area where our editors can give their ratings on the projects being reviewed. Next, we need to implement a way for readers of the site to provide feedback on the products. Extending the rating widget will accomplish 2 goals in terms of this tutorial series. 1, it will introduce us to players, a way to add custom browser-side JavaScript for powering our widgets. 2, we need to capture the reader response in the database, so we will get to learn about the API route configuration function and can begin to explore how we can interact with the database. We want to essentially duplicate our existing widget layout in order to add a section where readers can add a rating to a product review. However, we have to modify it a bit so that there is data passed to the widget player and the markup can be easily altered by data returned from the database. Open up the modules/rating widget/views/widget.html file and add a bit of Nunchuck's code to the top. This code will set a variable, widget ID, for use in our markup. We're getting this value from the data.widget object that is available in every widget. This is just like the data.page object available on pages. This value will be used to link a database record containing the data that the reader submits to the corresponding rating widget. Next, add the following code after the markup for the first column that has a class of card that we added previously inside of the div with a class of row. This markup adds the same three fields for quality, safety, and value that we added for displaying the values selected by the editor. We will circle back to how to use various data attributes when we add our player code. The important thing to understand at this point is that the player code can't access the widget or page data. Instead, any data to be used in a player should be added as a data attribute to the markup, which can then later be retrieved browser side by the player code. The only other thing of note in this markup, besides the 3 rows of stars, is the button that we've added at the very end so that the reader can submit their rating. While we could add an inline script to our widget for browser-side JavaScript, it makes more sense to add a player. Code added this way will be run when the editable area of the page is refreshed. This isn't guaranteed with inline scripts, which can lead to a loss of dynamic content and event listeners. Player code can be added to the UI source index.js file of any module, or to a file imported by that index.js file. Open the modules rating widget UI source index.js file that was created by the CLI tool and delete the contents. Paste in the code for this file from the written tutorial or the GitHub repo. This code is fairly long, and after pasting it in, I will collapse down the major sections and go through them one by one. There's a lot of code, and we aren't going to cover it all. We will go through the sections that are generally applicable to Apostrophe, but not the code associated with the behavior of the UI that is common JavaScript. Let's start by looking at the overall structure of the code. The player file must export a default function. In this case, within that exported function, we are defining a constructor, simple star rating. It initializes a new simple star rating object, sets up its properties and methods, and performs some initial actions like setting up star elements for the default rating and adding event listeners. This constructor function encapsulates all the behavior and properties needed for the star rating functionality. We'll only look at the code for this constructor briefly. The Apostrophe Widget Player's rating adds the player code to an object of Widget Players. Apostrophe Widget Players using the widget name and excluding the -widget suffix. We'll take a deeper dive into how this is structured. There are 2 additional helper functions included in the export. The first asynchronous function, send ratings to server, is responsible for initiating the database connection and transferring the data. We will also look at this one in depth. The second method, generate stars, is used for UI behavior and will only be mentioned when looking at the main player code. Starting at the beginning of the constructor, we define a helper function called fetch attribute, since we will be accessing markup attributes repeatedly to gather data passed from the data.widget object into the front-end markup. This function will get the specified attribute from the target element, and if it doesn't exist, it will pass back the default value. Next, we are initializing some variables. The most important one for this tutorial is default star rating. Remember that in the markup, each of our 3 sections had a data default rating attribute. Our target element doesn't have a data max stars attribute, but this would give us the ability to change the number of stars from just a slight change to the markup and a schema field asking the editor to assign a maximum number. Skipping slightly down in the code, there's a loop that adds all of the stars into our target element. While this isn't specific to Apostrophe, I'm pointing it out to remind you that our stars are being added using Font Awesome, just like in the editor card. The last method we are going to look at in our constructor is setCurrentRating. This method is called on the click of one of the rating stars and sets an attribute of data rating equal to the value of the star on the parent span before updating the display. This isn't an apostrophe specific method, just a valuable pattern to use for widget players. The Apos util widget player's rating object takes two properties. The selector property takes a value that identifies the widget HTML in the page. This selector was added when we first initiated construction of this widget. This selector does not need to be unique on the page. It is important because a user can add several of the same widget to the page. Apostrophe is smart enough to hook a specific player instance to a specific widget. The second property is player and takes a function with the DOM element matching the selector as argument. This is where you're going to add the code that manipulates and takes input from your widget. This is the code that should update the widget or add event listeners upon page load or refresh. As shown in this example, you can export additional helper functions that are used in the player. They will still be exposed on the front end, they just won't be refreshed with the rest of the code in the Apos util widget player's object. The code for the player begins by getting all the elements in our widget with a class name of simple rating. Looking back at our markup, each of the three sections, quality, safety, and value, have a span with this class. The array of these elements is passed into a for loop. Any existing star element arrays are removed, and each gets a new simple star rating constructor instantiated that adds the correct stars based on the data default rating. Next, we are selecting the submission button within the DOM so that we can add an event listener. We are also selecting the reader input card added by the new markup, both to allow us to get the widget ID value passed from the data.widget object through the attribute added to the markup, and to later change the HTML after the user makes a submission. The remainder of the player function adds an event listener to the submission button. Upon click, it first collects the ratings from each of the sections. It uses the data category and either data rating or data default rating attributes depending on whether the reader has selected a rating star. These ratings then get pushed to an array. The data attributes we are getting back are strings, so we are coercing them into numbers before storing them. Those ratings, along with an identifier for the specific widget, are passed to the sendRatingsToServer method. The values returned from that function are assigned to the average ratings variable for later use. Next, to make sure the user doesn't submit again until page refresh, the submission button is removed. Obviously, in production code, you would want a better methodology like storing a cookie to additionally prevent this type of behavior. Finally, we are replacing the existing markup for the reader submission section to reflect the running average rating in each category and the total number of reviews. The data returned from the server by the sendRatingsToServer function is used to populate the markup with the total number of reviews and stars representing the running average for each section using the GenerateStars helper function. Feel free to examine the GenerateStars function on your own. There are different methods for updating the database from a user submission. For the @CMS form extension, an emit is used that has the form document. The module has a handler that listens for that signal and then saves the form to the database. In this case, we're going to use an HTTP post and a route API configuration function in our module. This method starts by setting the base URL value to the base URL of the site and then constructing the endpoint for our post. In this case, we are going to create a route named submit. All the data for the body of the post is added to the data variable. Next, we set up a try-catch block to initiate the fetch and get back either response data or an error from the route. Again, any returned data is passed back to the click listener to repopulate the HTML displayed to the user. Except for a tiny bit of styling, setting up the API routes configuration method in the parent rating widget index.js file is the last step. Open the modules rating widget index.js file and add the following code after the components configuration method. Once again, I'm going to paste it in and then go back and explain. This configuration method returns an object with the main post root method called submit, but also three other helper functions. While these helper functions are fairly specific to the post root function, our API routes method could expose multiple post routes or roots for other HTTP verbs that could all utilize the helper functions. How you structure your code is up to you. Looking more closely at the post object. This object starts by declaring a post property that will take an object of all post methods. The submit method starts by getting values from the rec object. It then uses the widget ID that came originally from the data.widget object to retrieve a record from the database using that ID and the fetch rating document helper method. We are using the nullish coalescing operator to set rating document to an empty object if the record doesn't exist in the database, indicating it hasn't been created yet. The values the user selected, along with the values from the rating document object, are next used to calculate what the new average should be with the calculate new averages helper method. After updating the document using the update document helper method, the new averages are passed back as a response to the fetch request made by the player script. The fetch rating document method makes a simple database query. First, we set the criteria variable to an object with a key of _ID set to the widget ID. Every MongoDB record needs a unique _ID property. It is normally set automatically by MongoDB when you create a record, but we're going to create a record for every rating widget added and use their unique ID as the record ID. To find the desired record, we will specify the collection where we will be saving our rating documents, review ratings. To specify this collection, we are using self.apos.db.collection. This can be used to specify any collection, but many of the core Apostrophe collections have shortcuts. For example, to access self.apos.db.collection apos docs, we can use self.apos.doc.db. Within the calculate new averages method, we first get the averages for each section from the ratings document. If they don't already exist, we set them to -1. We also get the current number of ratings that have been submitted and default to 0 if the field doesn't exist. Next, we create a helper function, update average, to calculate the running average from past values. Finally, we return new averages for each of the sections and an incremented count of submitted ratings. Finally, we get to the last helper function that updates the database with our new values. It begins by destructuring the new averages object to extract the fields we will use to update the database: average quality, average safety, average value, and ratings count. Subsequently, it creates a criteria object that identifies the database document to be updated based on its _ID, which should match the supplied widget ID. The core of the function is the MongoDB $set operation encapsulated in the update query object. This query method is designed to update or create specific fields. If we were only increasing the ratings count, much like we would do when creating a widget that keeps track of likes, we could use the $inc method. The newly created criteria and update query variables are passed as arguments to an update1 MongoDB method. In this case, we are specifying that the record to be updated should exist in the review ratings collection of the database. We are adding an object with a property of upsert true as the third argument to indicate that if the document isn't found, it should be created and given the _ID specified in the criteria object and the values from the $set object. While this function is tailored for our specific post method, it's worth noting that its structure could be adapted to serve as a more generalized utility function. By doing so, it could execute MongoDB $set operations with arbitrary sets of key value pairs. If you were to spin the site up now, our widget would be functional. You can test this by adding it to an area on the default page. You should be able to select your rating as a logged out reader and have those ratings saved to the database. The reader card markup should then change to reflect the number of reviews submitted and the new averages. The only small thing we need to do is add some styling. We didn't cover the generate stars method that was added as a helper when creating the widget player code. If we take a quick look, we can see that it allows for the display of half stars based on the average that is returned. We didn't have fractional ratings for the editor, although the range schema field would allow that. So we need to slightly modify our modules, rating widget, UI, source, SCSS, _font_awesome_stars.scss file. Open that file and modify it with the following code. All we are doing is modifying the existing rule to add our font color to both the full star with a class of FA-star and the half star with a class of FA-star-half-alt. Now with this done, let's take a look at our completed widget on the page. Before spinning the site up, I'll add the widget to the lib/area.js file so that it can be added to the default page. In this case, it likely isn't necessary, but I'm going to delete the apos build and data/temp folders before bringing the site up with the apos dev flag enabled. Again, this will make sure everything is rebuilt, including our admin UI. Switching over to the site, we will create a new default page and add the widget. As you can see, the editor can enter values from 1 to 5 in each category. As soon as we add the widget, you can use the reader submission section to send data to the server and get averages back. If we log out and load the page, we can see that we are still able to submit values and we can get the averages back that provide half stars. In this tutorial, we explored how to build the rating widget, introducing async components in Apostrophe for adding dynamic markup to pages, ideal for incorporating database or API-driven content. We learned about widget players for integrating front-end JavaScript, enabling widgets to be interactive. We discussed transferring data from the backend to the front end using data attributes and setting up routes for client-side post requests via the API routes configuration function. Finally, we delved into Apostrophe and MongoDB, experimenting with queries, query builders, and modifying database records. The Pieces tutorial will provide a more detailed examination of these concepts. Moving forward into the next tutorial, we will look at the Apostrophe piece type through the creation of a review piece. This will also cover the creation of special page types to display single reviews or a filtered list. We will also revisit widgets, looking at using a widget to display a specific piece or list of pieces. Along the way, we will also talk about additional schema field types and options, as well as taking a look at how Apostrophe handles pagination. If you have any questions about this tutorial or want more help starting your Apostrophe CMS project, please join our vibrant community in Discord. You can join right now by following the link in the comments. We hope that you will continue along with our tutorial series and subscribe to the other great videos in our channel.